All right, thank you. Today we have a diagram on the board here, and this is parallel, right? They're asking us basically to calculate the vertical height and the volume of this diagram you see here. So the first thing we need to identify the vertical height of this parallel. What is the vertical height here? If you see on this board here, the vertical height is this dotted line here from V to M. So it means that, let's start something here quickly. So it means that V M is equal to the vertical height. So this V M is uniform. But to get V M, we see clearly that this parallel, the base is a rectangular base. How do we know that it's a rectangular base? You can see from B, A, E, D. We see that from A to B are 5 and also E here. So this is the length. This is the length here. B to D is the length, and on the side is the width. So we can draw a line because it's a rectangle. We can draw a line. So when we draw a straight line from here, you can add a word that if I have a rectangle, we draw a straight line, which we call the diagonal. That line will certainly divide the entire thing using the two equal part, creating a right angle triangle. So this is it. So it means that if this is a right angle triangle, it means we need to find B to E. So how do we do that? So let's start from here. So let's start with B, E. Since the right angle triangle, we use the Pythagorean theorem concept. So BE is the longest side. Of course, you can see it, which is the hypotenuse in the case. We say the square root of BE, which is 12 cm squared plus DE, which is 5 cm squared. So we take the side BE going to be equal to if you square 12, you 144 cm squared plus 25 cm squared. Of course, when we do this, we'll have 169 cm squared. Take the square root of it. 169 is just 13 cm. So it means that this entire line from here is other than 13 cm. But that is not our target point, but it helps us to get closer to our target point. Let's see the next point you see here. If I draw the line here, even though the line seems to be like it's hanging, but it's not actually hanging, it's also continuing to touch the diagonal. Don't forget it's a rectangular base. So when we touch this diagonal here, it means that this is how the diagonal appears. From this V point here, we have the slant height here. We have, so it means that this is from M, this is V, and this is E. See that? So the slant height here is 10 cm. So B to E is 13. So to find ME, which will help us to find the vertical height with the VE, we need to find half of BE. So let's find half of it. So it means ME is actually half of BE. So ME here will be equal to half of 13 cm. Obviously, ME will be equal to 6.5 cm. Great. So it means that here is 6.5 cm. You can see here, when the portion of the board is 6.5 cm. So this is a right angle triangle as well, because intercepting the line at the perpendicular point means that they create a right angle triangle here, right? So this point is like this. So if it is this way, it means that VE is the longest side of the triangle. So the vertical height, which is the vertical height of the parallel, is what we are about to find. So to use the same concept of the Pythagorean theorem. So it means that this is C squared. We are stated in the form. So V M will be equal to the square root of, meaning making this side, which is the opposite side, will be the circular equation. So we have 10 squared minus 6.5 square. V M will be equal to 10 square will be 100 minus. So when I take my calculator, 6.5 square or 6.5 times 6.5, it added 42.25. Alright? V M will be equal to, if you have 100 minus 42.25, you have 57.75. Yeah. So Vm will be equal to, take the square root of what we have there, the square root will be equal to, it's already 7.599 cm. So to have the root number, we take the problem up here on the side for space. So we take the problem here. Then Vm will be equal to, run this all because of the, going to be 8 is that. Set 8 cm here. So therefore, Vm is equal to the vertical height. We will find the vertical height of this pyramid. So this is the vertical height. So vertical height, this is the vertical height. So the next thing we are to find here, B, they ask us to find the volume. So what is the formula? The key thing here is the formula. If you know the formula, it's the formula of the pyramid is equal to 1 over 3, the base, the area of the base, right? But that clarifies on here. The area of the base can change because it's possible the base of the pyramid could be a triangle, be a square, or rectangle like a case. So we need to find the area of the rectangle. So I will use AB here to represent the area of the base, right? AB times the height. Do we know the height? Yes. The height in the case, the vertical height, we got the Vm is 8 cm. So what is our AB? Our AB will be used, will be calculated using the area of the rectangle. This is a rectangle. And we all know the area of the rectangle is equal to the length times the width. What is the length here? The length here is 12 cm. And the width here is actually 5 cm. So it means our AB will come out to be 12 times 5. AB will be equal to 60 cm squared. So it means that injecting this into the formula, swiftly we have 1 over 3. AB is already 60 cm squared times. What is the height we found? It was 8 cm. So I'm going to put everything in the calculator. When I say 60 times 80 equal to 480 cm cube, because cm squared and cm cube divided by 3. If I divide this, divide by 3, of course it will be 240 cm cube. So this is the volume of the pyramid. Thank you. Continue to follow the page.